Okay, so now we're going to practice what we've learned through this whole section in a couple different problems. So first practice is, are the following molecules chiral or achiral? If they're chiral, identify, so with a star, put where the chiral carbon is. So looking at this first one, I'm not going to try and pronounce that. I am very sorry, but let's look at each of these and see if we think that they're going to be chiral. So this carbon here has 2 hydrogens on it, therefore it has 2 groups that are same. We're looking for 4 groups that are different. So this carbon here has 4 different groups. It has a carbon going one way with a nitrogen on it. We have an aromatic group on one side, an oxygen, and then a hydrogen. So I'm going to put a star right here and then say that it is chiral. And then now we have citronellol. I know that one, or how to pronounce that one at least. So the only carbon here that has 4 different groups on it is going to be this carbon here. I'm going to draw in this hydrogen so that we're very clear. We have a hydrogen, a methyl group, and then it might be confusing because we have 2 different carbon chains, right? But those 2 carbon chains are very different. One of them has that double bond and a bunch of methyl groups on the end. The other one has an alcohol. So those are still 2 different groups, 4 different groups overall. So this is also chiral. Okay, glycine, it's the most basic amino acid that you have. And it, looking at the carbons, there's only 2 carbons here. One is a carboxylic acid in the carbon. So the only other carbon is this guy here, which has 2 hydrogens on it. So this is an achiral molecule. So I told you guys a little bit earlier that the reason we talk about chirality is because it's in nature. And I just said this is an amino acid. However, this is the only achiral amino acid that there is. And then the last one is alanine, which is also an amino acid that we'll be learning about. We have 3 carbons here. And if we look, that this carbon right here has 4 different groups on it, therefore it is chiral. Continuing on, do the following pairs of Fisher projections represent pairs of enantiomers or identical structures? We're looking for enantiomers or the same molecule. So I'm going to look and see, first off, are these mirror images? So if I put a dotted line, or we'll go ahead and replace that with our mirror plane. There we go. If I put that mirror plane there, we see that we do have a mirror. Overall, they are mirror images. So this, we'll use some colors. This hydrogen is in the same place. This methyl group is in the same place. The bromine is in the same place. They are, well, not the same place, but they are mirror images of each other. And then lastly, the top group is the same. I'll just underline. So overall, the red is the closest to the mirror, the pink is the furthest away from the mirror, and then the blue and the orange stay in the same place. So these are enantiomers. Okay, so let's do this one below. We have our same mirror image. Let's see if they're going to be opposites of one another. So we have chlorine on the top. Those are mirror images for sure. We have the hydrogen here, but we have hydrogens here as well, meaning that we have 2 of the same group or atom attached to the same carbon. So even though these methyl groups are exactly the same, this is a mirror image of each other. However, these are now going to be superimposable because they have 2 groups that are the same. So these are going to be identical. Okay, so now let's try another one. Put our mirror image here. I'm gonna just go ahead and put our mirror plane on all 4. Okay, so let's check to make sure that these are mirror images of each other and that everything is chiral. So we have more than one chiral center in this particular case because we have this carbon here, and we have this carbon here. So the red one and the orange one. So we need to compare both and make sure that they both change correctly. So on the very top, we have our aldehyde in both cases. That's an achiral carbon, so we're good there. Then we have these on the red carbon, we have hydroxides coming in towards the mirror, methyl groups going away from the mirror. So those are mirror images of each other. They are chiral carbons because there's 4 different groups. So we're good so far. The orange carbon, we have oxygens going away from the mirror, hydrogens coming in. So those look like they're enantiomers of each other for that chiral carbon. And then the bottom, we have the same thing, that's achiral on that carbon because we have 2 hydrogens on that carbon. So it's not a chiral atom. So these are enantiomers. Okay, and then our last one down here, let's look at this and see what it is. So again, we have our carbonyl going up to the top. Our nitrogens are coming in towards the mirror, hydrogens away, and methyl group on the bottom. These are definitely chiral. This is definitely a chiral carbon because there's 4 different groups on it, and they're oriented in the mirror plane. So these are enantiomers as well. Okay, and then our last one is draw Fisher projections of the following molecules. Are they D or L enantiomers? So I'm going to take this carbon chain here. Let's go ahead and number 1, 2, 3. I'm going to start with my numbering as high up towards the carbonyl as I can. So in both of these cases, we have aldehydes. So that aldehyde then, so because my carbon chain, I want the carbon chain to go back, I'm going to pick that up and turn it now the other way. So the carbonyl is kind of going back to do my Fisher projection. I'm going to draw my carbonyl, my aldehyde. I have 1 chiral carbon, so 1 intersection, and then carbon 3 is going to be CH2OH. And then because I took that backbone, so those 2 carbons going down are now going to go, you're going to pick them up and you're going to put the carbonyl up into the back so that those, you gotta do kind of mental gymnastics right here. So that the oxygen and the hydrogen, which were like this, now are going to come up like this. So if my pointer finger was the oxygen coming out towards me, and the hydrogen was my ring finger, if I picked those up and pointed them towards me, the oxygen is then on the right, hydrogen is on the left. In order to determine D or L, we look at the furthest chiral carbon from the carbonyl. This is on the right side, so this is going to be the D enantiomer. Okay, now we have to do the other one. So it's the exact same molecule, but just these 2, the oxygen and the hydroxide groups, the hydrogen and the hydroxide are switched. So let's go ahead and draw that out. 1, 2, 3. Okay, so now at carbon 2, the oxygen was going back, but now we have to spin it towards us. So the oxygen would be on the left side, hydrogen on the right side. Looking at that, furthest chiral carbon from the carbonyl, it's on the left side, so we have the L enantiomer. Okay, so that's our chiral molecules, and we'll get into chiral monosaccharides in our next section.